Dear 11th standard students, today we are going to see the topic of properties of components of vector in kinematic lesson. Before going to see the properties of components of a vector, what is the components of a vector? Already you know that, already we discussed. What is a component of vector? For example, a vector resolved into three components along the three direction, x direction, y direction, z direction. A vector, it can be resolved into three components along the three coordinate axes, ax I cap plus ay j cap plus az k cap. Then let me assume one more vector, b vector. It can be resolved along the three coordinate axes into the components bx I cap plus by j cap plus bz k cap. There are two vectors. A is one of the vector, B is another vector. These two vectors resolved into three components along the x direction, y direction, z direction. For example, A vector, Ax is the component of A vector along the x-axis. Ay is the component of A vector along the y-axis. Az is a component of A vector along the z-axis. For example, another vector, B vector. Bx is the component of B vector along the x direction. By is the component of B vector along the y direction. Bz is the component of B vector along the z direction. So these are the components of a vector. Now we are going to see one of the properties of components of a vector. Let me assume A vector and B vector. A vector which is equal to B vector. It is one of the properties of components of vector. You write Ax I cap plus Ay j cap plus Az k cap, which is equal to B vector Bx I cap plus By j cap plus Bz k cap. If A vector which is equal to B vector, then corresponding components are equal. So you see that A vector along the x direction, component of A vector is Ax, which is equal to B vector along the x direction, Bx. Both the components are equal. So therefore, Ax which is equal to Bx. When comparing the components of A vector and B vector along the x-axis, comparing the components along the x direction, then Ax which is equal to Bx. Then comparing the component along the y-axis, y-axis or y direction, components of A vector along the y direction, which is equal to components of B vector along the y direction, then Ay which is equal to By. Then comparing the components of A vector and B vector along the z direction, along the z direction or z axis. So Az is the component of A vector along the z direction, Bz is the component of B vector along the z direction. So if A vector which is equal to B vector, then components are equal along the z direction, then Az which is equal to Bz. It is one of the properties of component of vector. If A vector which is equal to B vector, then corresponding components are equal. Ax which is equal to Bx, AY which is equal to BY, AZ which is equal to BZ. So dear students, I finished one of the properties of component of a vector, A vector which is equal to B vector, corresponding components are equal, AX which is equal to BX. Whenever comparing the components of A vector and B vector along the X direction, AX is equal to BX. Compare the A vector and B vector along the Y direction, we comparing the components AY is equal to BY. We compare the components of A vector and the B vector on the Z direction, AZ which is equal to BZ. So dear students, next we go to see one of the important problem related to properties of components of vector. To see your textbook, example 2.10. See the question, compare the components for the following vector equation. So this is the question, compare the components, comparison of components for the following vector equation. Here, I write there are two equations. First A which is equal to F vector which is equal to M A vector. F vector which is equal to M A vector. Here F vector is F is the force, is a vector quantity, M is the mass, is a scalar quantity, A vector is the acceleration, it is a vector quantity, M is the positive number. F vector can be resolved into three components or resolved into three components along the three direction. F vector which is equal to Fx I cap plus Fy j cap plus Fz k cap. So why we resolve the three components along the three direction? Because force is a vector quantity. That's why we resolve three components along the three direction, x direction, y direction, z direction. Then mass is a scalar quantity. Then acceleration is a vector quantity. It can be resolved into three components along the three direction. A vector is equal to Ax I cap plus Ay j cap plus Az k cap. So it is equation number 1. This is equation number 2. This is equation number 3. Equation 2 and 3 substitute in equation 1. Equation 3 and 2 substitute in equation 1. Force vector can be written in the three-dimensional form Fx I cap plus Fy j cap plus Fz k cap, which is equal to M. A vector can be written in the three-dimensional form Ax I cap plus Ay j cap plus Az k cap. Then Fx I cap plus Fy j cap plus Fz k cap, which is equal to, take the product of vector with the scalar M Ax I cap, M Ax I cap plus M Ay j cap, M Ay j cap plus M Az k cap, M Az k cap. Now see the students, we compare the components of corresponding vectors. Comparing the components along the x direction. So Fx Max is the comparison of components along the x direction. Fx, which is equal to Max. This is equation number 4. Now comparing the components along the y direction. along the y direction. See, component of force vector along the y direction, then component of, in his right hand side equation, MAY along the y direction, Fy which is equal to MAY, equation number 5. Next, comparing the components along the z direction. Along the z direction. So, Fz which is equal to MAZ. So, this is the comparison of components along the x direction and the y direction and the z direction. Fx is equal to MAX, Fy which is equal to MAY, Fz which is equal to MAZ. See the only one vector equation. F vector is equal to MA vector, which is equivalent to Fx I cap plus Fy j cap plus Fz k cap, which is equal to Max I cap plus Ay j cap plus Az k cap. So it is also only one vector equation, but we get the three scalar equation. Fx is equal to Max, Fy which is equal to May, Fz is equal to Maz. So only one vector equation, but we get three scalar equation. Fz which is equal to Maz, Fy is equal to May, Fx is equal to Max. These are the three scalar equation from only one vector equation. Dear students, in the same problem in the textbook, example 2.10, we go to see another division B. P vector is equal to 0. So, P vector is nothing but a momentum vector. Momentum is a vector quantity. That momentum can be written in three-dimensional form in the Cartesian coordinate system. P vector is equal to Px I cap plus Py j cap plus Pz k cap. Then 0 which is equal to 0x I cap plus 0y j cap plus 0z k cap. Then P vector is equal to 0, then Px I cap plus Py j cap plus Pz k cap, which is equal to 0x I cap plus 0y j cap plus 0z k cap. Now we compare the components along the x-axis. Comparing the components along the x-axis. Compare the components along the x-axis. Px I cap, 0x I cap. So Px which is equal to 0. Then comparing the components along the y-axis. See, Py, comparing the components along the y-axis, Py which is equal to 0y. So, Py which is equal to 0. Then comparing the components along the z-axis. Z-axis, Pz which is equal to 0z. 0. So see, only one vector equation, P vector is equal to 0, or this is the only one vector equation, but we get a three scalar equation. Px is equal to 0, Px is equal to 0, Py which is equal to 0, Pz which is equal to 0. So only one vector equation, this is only one vector equation, but we get a three scalar equation, Px is equal to 0, Py is equal to 0, Pz is equal to 0. These three scalar equations. Dear students, next we are going to see one more solved problem, example 2.11, on the basis of comparing the components of a vector. Determine the value of t. Determine the value of t from the given vector equation. See the vector equation 5j cap minus tj cap, which is equal to 6j cap plus 3tj cap. Rearrange that equation. Rearrange the equation 5j cap minus 6j cap, which is equal to 3tj cap plus tj cap. So 5j cap minus 6j cap, it's the minus j cap, which is equal to 3tj cap plus tj cap, 4tj cap. Compare the components. Along the y direction or y axis. So minus 1, because along the y axis value minus j cap is a unit vector magnitude 1 which gives the direction along the y axis. So minus 1, which is equal to 4t. But in our aim we are going to calculate t. So therefore t, which is equal to minus 1 divided by 4. So we see next one more solved problem in the textbook, example 2.12. Compare the components of vector equation. You see one vector equation, f1 vector plus f2 vector plus f3 vector, which is equal to f4 vector. There are 4 vectors. Sum of the f1 vector, f2 vector, f3 vector, which is equal to f4 vector. First we write f1 vector in the component form, 3-dimensional coordinate axis. f1 vector is equal to f1x I cap plus f1y j cap plus f1z k cap. Then f2 vector in the 3-dimensional form, Cartesian coordinate system, f2 vector is equal to f2x I cap plus f2y j cap plus f2 z k cap. f3 vector can be expressed in 3-dimensional Cartesian coordinate system in the component form, f3 x I cap, f3 y j cap, f3 z k cap. Then f4 vector can be expressed in 3-dimensional Cartesian coordinate system, f4 vector, f4x I cap, f4 y j cap, f4 z k cap. So all these 4 equations substitute in equation 1. We get f1 vector f1x I cap plus f1y j cap, f1z k cap plus f2 vector f2x I cap, f2y j cap, f2 z k cap plus f3 vector f3x I cap, f3y j cap plus f3 z k cap, which is equal to f4 vector f4 x I cap plus f4 y j cap plus f4 z k cap. See the students, now we compare the components along the x direction, along the y direction, along the z direction. Comparing the components along the x-axis of x direction. F1 vector along the x direction, component of F1 vector along the x-axis, F1x. In the F2 vector, component along the x-axis, F2x. Then third vector along the x-axis, F3x, which is equal to F4x. Then comparing the components along the y-axis, along the y-axis or y direction, F1 vector, component of F1 vector along the y-axis, F1y. Component of F2 vector along the y-axis plus F2y, plus component of F3 vector along the y-axis, F3y, which is equal to component of fourth vector, F4 vector along the y-axis, F4y. Now comparing the components along the z-axis, z-axis. So component of F1 vector along the z-axis, F1 zx, plus component of F2 vector along the z-axis, F2z, plus component of F3 vector along the z-axis, F3z, which is equal to component of F4 vector along the z-axis, F4z. So after comparing the components along the x-axis, components along the y-axis, component along the z-axis, we get the three equation. Equation A, equation B, equation C. Now comparing the components along the z-axis, F1 vector, component of F1 vector along the z-axis, F1z, plus component of F2 vector along the z-axis, F2z, plus component of F3 vector along the z-axis, F3z, which is equal to component of F4 vector along the z-axis, F4z. So these are the three equation. Equation A, equation B, equation C. These three equations belongs to comparing the components of vectors in the left hand side and the right hand side. So dear students, next we move another one small topic in your textbook, position vector. So what is position vector? Position vector is a vector which describes the position of a particle at any instant of time during its motion with the one reference frame or with respect to the coordinate axis. Let me assume three-dimensional Cartesian coordinate system. Positive x-axis, negative x-axis, positive y-axis, negative y-axis. Say three-dimensional Cartesian coordinate system. X-axis, y-axis, z-axis, origin of the coordinate system. I cap is a unit vector along the x-axis, j cap is a unit vector along the y-axis, k cap is a unit vector along the z-axis. So I cap, j cap, k cap are the three unit vectors which denotes the direction along the x-axis, direction along the y-axis, direction along the z-axis, but the magnitude value 1. Let me assume if a particle travels in space, that position of the particle at any instant of time during its motion in space can be described with the help of some one reference frame or with the one Cartesian coordinate system. See the position of a particle at that instant of time during its motion. So position vector is a vector starting from the origin along the x-axis, along the y-axis, along the z-axis. So this is y-axis because this is y-axis which is equivalent to this value y. This is x-axis which is equivalent to that x value. This is z-axis which is equal to this line z-axis. So this is the position of a particle at any instant of time during its motion in space p x comma y comma z. So this is position vector r vector. So position vector is a vector, keep it in your mind, it is one of the vector, but it describes the position of a particle at any instant of time in space based on three-dimensional Cartesian coordinate system from the origin to this point. That value is nothing but a position vector. So position vector is a vector quantity, both it has magnitude and direction. Position vector can be represented in three-dimensional Cartesian coordinate system. R vector is equal to Rx I cap plus Ry j cap plus Rz k cap. So R vector is a position vector which is equal to position of the or component of R vector, position vector along the x-axis Rx. Position of the R vector or component of R vector along the y-axis Ry. Component of R vector along the z direction Rz. So position vector can be represented in three-dimensionally. R vector is equal to Rx I cap plus Ry j cap plus Rz k cap. Suppose if any one particle travel in a plane, it can be represented, position of the particle at any instant of time can be represented by the position vector, but with the help of only two coordinate axes. So on the basis 2 dimension, position vector R vector is equal to Rx I cap plus Ry j cap. This is if a particle traveling in a plane, position of the particle at any instant of time can be described with the help of only two coordinate axes. So position vector R vector is equal to Rx I cap plus Ry j cap. So next, on the basis of position vector concept, we go to solve one textbook problem. Example 2.13. Determine the position vector for the following particles which are located at points P, Q, R and S. See the picture, it is one of the graph. First, determine the position vector at a point P. See the point P, this is point P. This is Cartesian coordinate system, two-dimensionally. First we choose the origin of the Cartesian coordinate system, O. From the origin, see the P point. So P point is located on the positive x-axis at the value 3. 0, 1, 2, 3. So we can write position vector at the point P. At the point P. See, from the origin 1, 2, 3. So position vector R vector at a point P means Rp vector which is equal to only along the positive x-axis. That the entire position vector Rp vector is lying along the only positive x-axis. So therefore 1, 2, 3, 3 I cap. So next, we are going to calculate the position vector at a point Q. See the point Q. This is point Q. Position vector at a point Q. So the point Q is lying in the plane positive x-axis and the positive y-axis. That point Q, you see clearly see the picture at point Q lying in a plane plus x-axis and the plus y-axis, lying in the xy plane, Q point. So therefore, that position vector at a point Q from the origin R vector at a point Q, which is equal to 1, 2, 3, 4, 5. 5 x I cap along the x-axis. Then see the y-axis. 1, 2, 3, 4. Positive y-axis plus 4 5 I cap plus along the y-axis 1, 2, 3, 4. 4 j cap. This is position vector at a point Q starting from the origin O. Then position vector at a point R. See the point R. This is point R. This point R is lying along the negative x-axis from the origin 1, 2. So position vector R vector at a point R, which is equal to 1, 2 minus 2 I cap. That's all. That is the position vector at a point R. The next position vector at a point S. See the point S. This point S is lying in the plane positive x-axis and the negative y-axis. This point S is lying in this plane. So position vector at this point S, position vector R at a point S, which is equal to 1, 2, 3, 3 I cap. Next 1, 2, 3, 4, 5, 6. So minus 6 j cap. This is the position vector at a point S. So from this graph we find the 4 position vector at a point Q, at a point P, at a point Q, at a point S, at a point R. So there are 4 position vector, RP vector and RQ vector and RR vector, then RS vector. These are the 4 position vectors based on the point P, Q, R, S. So see the students, in this video class only I discussed very small topic. One is properties of components of a vector, another one is position vector. Properties of components of a vector very simple. If there are 2 vectors, both the vectors is equal, then the components are equal. That is the properties of components of vector. On the basis of properties of components of vector, we discussed a few problems. Next topic, position vector. Position vector is a vector simply, but it denotes or it describes the position of a particle at any instant of time during its motion, either 2-dimensionally or 3-dimensionally. In the 3-dimensional equation, position vector R vector can be described or expressed. R vector is equal to Rx I cap plus Ry j cap plus Rz k cap. So Rx I cap, Rx is the position vector on the x-axis, Ry is the position vector on the y-axis, Rz is the position vector along the z-axis. So in 2-dimensionally, position vector can be expressed. R vector is equal to Rx I cap plus Ry j cap. On the basis of position vector topic, we discussed one important problem in your textbook, example 2.13. Only one problem we found. There are 4 vector equation: position vector at a point P, position vector at a point Q, position vector at a point R, position vector at a point S. So simply position vector is a vector. It denotes the direction and also magnitude starting from the origin. It is one of the position vector at a point P, position vector at a point Q. It is also starting from the origin. Position vector at a point R. It is also starting from the origin. Position vector at a point S. It is also starting from the origin. So, further topic we will discuss later in some other physics faculty. Thank you.